What is the chemical reaction? Observe and answer. At the left side, we have reactants, while on the right side, we have products. As you can observe in reactants, we have breaking up bonds of hydrogen and oxygen. Here we have two free or four free hydrogen atoms and two free oxygen atoms. In the products, we have formation of new bonds. If you have H and H, they are free. H and H, they are free. Here you have O and O, they are free right now after breaking up bonds. H, O, H, H, O, H. Here we have formation of new bonds in the products. That's why we said chemical reaction is breaking up bonds of reactants molecules and forming new bonds in the products molecules. This is a kind of chemical reaction. Here we have reactants and here we have products. My question is, how many reactants we have here? Magnesium, this is one. I won't consider the coefficient. I'm just counting the number of substances in the reactants and oxygen. Here we have two reactants, right? How about products? We have only one product. As we said, coefficient is not counted. Here I have magnesium oxide, it's a product. When two reactants combine with each other to form one product, this is known as a combination or a composition or a synthesis reaction. Again, combination, composition and synthesis reaction. Two reactants or more than two reactants, and here we have one product. This is combination reaction. So synthesis reaction or combination reaction, if two or more simple substances like that, they form one product, like C plus O2. Here we have CO2, two reactants, one product. CaO, calcium oxide, plus water. Here we have calcium hydroxide, two reactants and one product. Therefore, any chemical reaction in which you have two reactants or more than two reactants and one product, it's known as synthesis, combination, or composition reaction. On the other hand, if you observe this chemical reaction, you will find that we have only one reactant, ammonium chloride. Here we have ammonia and hydrochloric acid, one reactant which decomposes into two products. This is known as decomposition reaction. In decomposition reaction, I have one reactant which decomposes or breaks down into two products. For example, if I have carbon monoxide, CO, I have C plus O. It's a kind of decomposition. Here, on the other hand, I have calcium hydroxide, one reactant, which decomposes into calcium oxide and water. This means I have one reactant that decomposes into two products. What happens here? Try to guess. This is Zn, zinc. Here we have copper, and here we have chlorine, okay? Zn replaces copper. So I have ZnCl2, and here Cu is out. Zn replaced Cu. It's known as single replacement reaction. In single replacement reaction, one reactant replaces another reactant, and it's a compound. How many replacements we have here? It's one. Zn replaces Cu. Single replacement or single substitution reaction, it's a chemical reaction in which one reactant replaces another reactant. Here I have AC, and B is out. For example, if I have K plus NaCl, I have two reactants and two products, by the way, so it's not considered as a composition or decomposition. K replaces or substitutes Na. I have KCl and Na is out. Chlorine plus sodium bromide. Cl replaces Br because it's negative, both are nonmetals, and here Br is out. It's kind of single replacement too. I have a question for you. All of us have observed the experiment of sodium and water. All right. Here we have a chemical reaction, right? So in this chemical reaction, I have sodium replaces hydrogen. I have 2NaOH, and I have hydrogen. This is the explosion we have in this chemical reaction. It's a kind of single replacement. While when you add some gold to water, for example, here we have no change, we have no chemical reaction. What is the reason for that? I need you to observe this table, which is known as chemical activity series, or CAS. What is CAS? It's the arrangement of elements based on their chemical activity. Elements at the top, they are very active, while elements at the bottom have very low activity. As you go down, the activity decreases. Here I have the hydrogen of water. At the first example, sodium at the top, which means it has a higher activity. That's why it has the ability to replace hydrogen. It's stronger than hydrogen. While on the other hand, I have Au is here. This is gold. Its activity is less than the activity of hydrogen. That's why it doesn't have enough strength or enough activity to replace it. It's weaker than hydrogen. That's why I have no chemical reaction here. The question here, chemical activity series, is the arrangement of elements based on their chemical activity. Elements with high activity are at the top, while as we go down, the activity decreases. Double replacement reactions. In this example, I have AB and CD. They are two reactants, and I have two products. It's not considered as a composition or decomposition reaction. What happens here that I have breaking up bonds in the reactants, A with D. This is the first substitution. And I have C with B. This is the second substitution. How many substitutions we have here? Yes, two. That's why it's known as double replacement or double substitution reaction. For example, I have AgNO3, two reactants, and here we have two products. What happens when you have two compounds like that? AgCl. AgCl, this is the first substitution. NaNO3, this is the second substitution. NaNO3. If you have two compounds, two substitutions, or two replacements, this is known as double replacement or double substitution reaction. The last type of chemical reactions is known as combustion. What is combustion? Before studying combustion, we have to study something is known as hydrocarbons. I give you a hint about hydrocarbons or organic chemistry in the previous session. Organic compounds, they are hydrocarbons. Hydrocarbons mean they contain carbon and hydrogen in their chemical composition, like fuel, paper, and plastic. When any hydrocarbon combines with oxygen, we have carbon dioxide and water and heat. This is known as combustion reaction and its factors. For example, CH4 hydrocarbon with oxygen. I have just carbon dioxide and water vapor. This means that it's a kind of combustion reaction. It's fixed. My question is, what is the type of the following reaction? 2K plus 2HCl. Here we have 2KCl plus H2. Two reactants and two products. Of course, this chemical reaction is not a composition or decomposition. And by the way, here I have no hydrocarbon. It's not a combustion. So what we are gonna do right now is an element K replaces H. I have KCl and H is out. How many replacements we have here? So it's a kind of single substitution or single replacement. The second chemical reaction is 2Na plus Cl2. How many reactants do you have? Yes. How many products? Yes. It's a kind of combination, composition, or synthesis. How about the third one? 2Ki PbNO3. By the way, Ki is not one element. Here we have two elements, potassium and iodine. How can I know this? If you find two capital letters, K and I both are capital, this means that you have two different atoms. If you find capital and small like that, Pp, this is lead, it's one element. Here, K, Pb, I, KNO3, 1, 2. How many substitutions and compositions we have here? Here we have two substitutions or two replacements. That's why it's kind of double substitution reaction. HGO. How many reactants we have? Yes, one. How many products? Two. It's a kind of, yes, decomposition. A hydrocarbon plus oxygen, carbon dioxide, and water vapor. It's a kind of, yes, combustion. Like the fuel in your car, it's a hydrocarbon. When you use the fuel paddle, here it's a reaction with oxygen. You have the product at the exhaust, it's a carbon dioxide and water vapor.